Hey everyone, my name is Peter Zaitsev, and I am the founder of Percona and also a very active advocate of open source databases and open source overall. And today we are going to talk about running databases on AWS, the choices and trade-off, and of course we'll focus on open source database, but I thought it would make sense to cover overall ecosystem. So specifically, we'll talk on the ways to run a different databases on AWS, the place of open source database and range of what kind of open source and open source comparability exists at AWS, and the choices and the trade-off. Now, before that, let's talk why do we want to focus at AWS specifically. I just, a few days ago did a poll on my LinkedIn, which is, well, I think this kind of biased of a lot of open source focused technologists about the cloud they use to run the database. Well, they run the infrastructure, including databases, right? And you can see what AWS is very much the leader across the other US popular cloud choices. And if you consider the other response, where some people commented what they use all of the clouds or multiple clouds, right? Then you can see what AWS lead is even more. So again, if you're speaking about United States and probably a lot of the Western world overall, AWS is their most important cloud vendor, unquestionably, when you are speaking about running your open source databases. Now, how does AWS, in my opinion, and again, I have no affiliation to AWS on any specific inside knowledge, which kind of just my observations. How do they really approach running databases? I think AWS is very good at focusing on giving customers what they want, but while they're doing that, they also want to steer them towards solutions which make AWS money, making AWS money now and in the future, like trying to get people, locked into solution which would be harder for them to leave. And also AWS is good at embracing competition. So they offer solution from many vendors you would think are bitter competitors of AWS. Like you can find Oracle database, you can find Microsoft SQL on AWS, and then so on and so forth. So if you think a way to run databases on AWS, I think it can be put into three different buckets. One is you run databases, what is called like fully managed databases or database as a service, something like AWS, RDS, Amazon Aurora. There is also a ways to self-host the databases, like also self-manage. And here we have two very distinct ways, which I think one is this legacy approach using EC2, and then the cloud native approach, which is based on Kubernetes. So what kind of databases AWS offers? Well, there is quite different buckets I could put them in, right? One is there is, of course, a classic proprietary databases, which you can run now on AWS, such as Microsoft SQL Server or Oracle. There are a lot of partner databases, cloud and non-cloud, which you can find on AWS Marketplace. Things about Databricks or Snowflakes. Then there are specific AWS cloud database which only exists on AWS. DynamoDB, TimeStream would be example, but there is really much more. The third class would be enhanced open source databases, something like Amazon Aurora, where they took open source solution, they made it better, right? Didn't release the changes to open source, right, and host that. And then there is also relatively vanilla open source databases on Amazon RES. You can see MySQL, you can see, Postgres, you can see Valky, right, which are hosted with very little changes, especially with little user visible changes. Now, the open source those days is very powerful brand. And because of that, you can see it's very commonly used for marketing different solutions, and not just by Amazon. I think every vendor play it the same way. And here we need to understand there's like 3 different ways. Like one is the open source compatible, right? The great example here is MemoryDB, which is something which is Redis and Valky compatible, but this is entirely different effort, right? It does not have any kind of, well, or maybe it has, right? But it's not based on the same, it's not claimed to base on the same source code as the open source project it's comparable with, right? Next example here would be, while MongoDB is not really open source, it's source available database, it's also have DocumentDB, which is comparable, protocol compatible, but is a distinct development effort. Then there is open source based or enhanced open source, such as Amazon Aurora, and there is pretty much hosted open source as Amazon RDS. There, well, obviously, these are obviously very different solutions when it comes to comparability and vendor lock-in and so on. When it comes to vendor lock-in, I think it's important to highlight what, even if you're speaking about the hosted open source, right, which comes with a minimal to known changes, it is still possible what if you run things on AWS, you're relying on some behaviors which happen to be different because of configuration, or you're relying on what Amazon provides as a management plane. So in reality, the only way to ensure what you are not really locked in the software in the cloud is to test it. So you want to make sure what you are not locked in, for example, to Amazon RDS Postgres and can move to vanilla Postgres if you ever need to, well, is by making sure you test your software with both. I just wanted kind of to highlight that, because I've seen over time people just, assume because the software is stated as compatible, they just run with that software. I assume it's easy to move away if they need to, and then find, well, it's not as easy because of some, little nuances. With that, let us drill into the open source based database solutions so on AWS. And by open source based, I mean either simply hosted open source databases or some enhanced databases. So thing to note in this case is what AWS, I think, is a very, very good in listening to their customers. So if you look at the mature solutions, which sort of like a complete this preview stage and which have been around for many years, they are actually make sense for certain customers in certain situations. So there is no one size fits all advice where we can say only use this approach and it would be great. So let's look at the options of that. So if you think about the extended open source, right, or open source based, this is something as Amazon Aurora as example, right? This software typically comes with more features. It can give you better performance, maybe better availability, or often Amazon focused on some better security, like integration with Amazon security systems, and so on and so forth, as well as integrating with AWS ecosystem as a whole. In this case, well, because obviously Amazon puts more effort and engineering in that databases, it can charge more premium pricing, so it tends to be more expensive, and that offers one-way comparability overall, right? So because it offers some additional features, right? So if from feature or performance profile, your stuff can run on Amazon Aurora, that's not necessary. It would be able to run on the RDS or on vanilla open source database. The next would be so-called fully managed open source, right? Then it's their examples here would be something as Amazon RDS or um, for MySQL Postgres and some other, which comes for us with a minimal user-facing changes. There are still some, right? Like, for example, you wouldn't get the root user access, right, or super user, and not be able to, change certain things and so on and so forth. That gives us kind of this balance. On one extent, there is a lot more simple management, right? You can just, provision database, and it comes already with database, with high availability, backup, monitoring, everything for you, kind of maybe automatic updates, all the kind of good stuff. But also, it comes with a limited flexibility, right? So that means if you want to figure out some very advanced deployment configuration, it uh, may not work. And it offers a lower premium compared to self-hosted option, right, or just infrastructure costs, and also it's lower at vendor lock-in, right? So that's your trade-off between, let's say, Aurora and RES at a high level. Then there are self-hosted options. Self-hosted options give you a lot of flexibility. It's kind of, hey, choose your own adventure, right? And there's a good and bad with that. You can come up with some very exotic ways to configure and deploy your system, and that can be awesome creativity, or that also maybe, taking some unknown risks which you may just don't know about, and where Amazon doesn't allow certain kind of configurations because after running millions of instances for many years, they know this is kind of something to avoid. In this case, of course, you are just paying for infrastructure cost if you're running open source software, right? And if you have some sort of relationship with a vendor to get help for support, managed services, wherever, that is an extra. That is, of course, if that is harder to manage because you take that all on you, but at the same time, it is lowest lock-in because if you self-host, well, you typically can apply pretty much the same approach on a different clouds as well as on-prem, right? So if you are running a hybrid cloud, right, or wherever, right, then that's private cloud, right, that can work very well for you. Now, I think it's good to understand this interesting relationship between how reasonable is the self-hosted approach and environmental scale, right? If you're just saying, hey, I have just need like a one database of a small size, right? Well, then probably paying a few $100 or to extra to Amazon for convenience makes a lot of sense. But if you look at the huge deployment environments, right, typically that experience to build and maintain the automation framework, and that's kind of how it's done, it usually is a lot of fixed costs, right? And it doesn't really change that much of your environment scale. So if you look at some very large organizations, for them, directly financially, it make sense to really self-host that. Though I think some organizations just still would not like to take the risk, right? And their idea is saying, hey, we choose to pay the experts like Amazon and just focus on what we are doing best, right? So in certain case, I think that grows to be not just financial, but their philosophical approach. And of course, there is also like a third way saying, hey, we as an organization don't want to take it in-house, but we want to get more flexibility. So we would work with some vendor like Percona to help us to do that. So how can we self-host? There are different ways here. One is we can have EC2 based deployments. The good thing with EC2 is what that is similar to VMs, virtual machine, and bare metal deployments. So you may have like a lot of people with a lot of experience doing that on-prem, and now you're moving to the cloud. That makes it very, very simple for you. And also, this makes it rather, easy to port between different clouds, because if you think about these abstractions as your storage, your network, your VMs, it's very much commodity. Like pretty much every cloud provides that. There are some, abstractions layers you can use, right, to write in your automation and so on and so forth, right? But you typically have to build the automation from their Lego blocks, right? There is no some universal open source standard which can take it with any bare metal or EC2 environment, right, and manage uh, your database on them. There are some good blocks, like for example the orchestrator, right, which was popular for MySQL and now getting PostgreSQL support can be awesome, right? Some other tooling, but there is nothing which is to say, hey, this is essentially the industry standard, right? And again, you can do that with in-house database experience or a partner, wherever works better for you. So this gives us also a lot of flexibility what you can do, right? You can use some complicated replication topologies, for example, for better or for worse. You can use your own builds, bring some unusual extensions, and don't have to sort of like, check into with whatever Amazon supports. You can use some different storage engines which Amazon may not support, right? So, such as, MyRocks for in MySQL through Percona server. You can do some creative stuff saying, hey, I want to store my data in and local NVMe or even RAM, right? Because I just want that sort of like a guaranteed kind of very real-time response time, and my data set is small, and maybe I don't even care about high availability, right? Because I can always load up those data from some other source, right? So a lot of flexibility you can say, but again, you need to really know what you're thinking, because with great power comes great responsibility of doing things right and not hurting your business. If you look at Percona, we of course have a lot of solutions which you can use if you are using this kind of employment. We have Percona builds for MySQL, MongoDB, Postgres, right, with some additional features which you consider. We have Percona Toolkit, which has been used by a lot of DBAs for more than a decade to safely perform number of database operations. We have a tool called Percona Monitor and Management, which is their open source observability solution for databases with awesome AWS support. And of course, we have Percona Support and Managed Services, which handled many, many customers on AWS through the years. The other approach, though, is instead of using their EC2 and kind of bare metal-like employment, is use Kubernetes instead, right? Kubernetes-based employment. And an interesting thing about the Kubernetes is it became ubiquitous right now, right? You can run it on-prem, you can run it on your laptop, you can run it on the edge. right, which makes it absolutely awesome in terms of portability. What I think is also interesting is what the Kubernetes is part of CNCF ecosystem, right, which has grown massive, right? There are now a lot of different things that you can use besides running your databases in Kubernetes. So we can see many companies really adopt those cloud native approaches, which are also based on running a lot of stuff on Kubernetes. And another thing I think which is very cool in that Kubernetes-based cloud-native approach, which speaks to a lot of development team, is what it supports infrastructure as a code, which is declarative, versioned. And yes, of course, you can also do that with kind of a EC2-based bare metal VM, but that is not really native in that ecosystem, right? Like that, a lot of people grown in that stuff using a different approach, and which is their Kubernetes is ecosystem is designed for that. When it comes to Kubernetes, you of course could ask wherever you should even run your database on Kubernetes, right? And I remember like 5 years ago, there was a lot more concern if you even have to do that, right? I think as Percona, especially for some of the database technologies, we implemented their first open source operators, and to run them in the Kubernetes environment. But I think right now it is become much more accepted. Though I would say still some people hesitate to wherever that is feasible. And frankly, there are probably some scenarios in which case running a database on Kubernetes may not be the best. If you're interested in running databases on Kubernetes and in general data-intensive workloads, I would check out Data on Kubernetes community. I think this is kind of awesome, and you can see a lot of best practices, learn from experts which run database on Kubernetes, maybe get some more expertise with that. Now, here is some stats, right, which is probably about a year old, so numbers are probably even higher right now. But there is a survey which CNCF did on Kubernetes, which shows what about 90% of respondents believe Kubernetes is ready for stateful workloads as databases, and 70% are already running such stateful workloads in production, right? So again, overall, it has become the mainstream already. And if that doesn't convince you, I would say what a lot of database as a service solutions, right? They're actually using Kubernetes underneath, right? So that is pretty common, right? And people are able to build reliable, high performance, cost-effective solution on Kubernetes for hosting databases, and so can you. With that, let's talk about Kubernetes on AWS. There are really two ways you can run Kubernetes on AWS, and one is fully managed, right? This is also known as Amazon AKS, Elastic Kubernetes Service, or you can just use AWS as a bunch of VMs and self-host Kubernetes on that. The difference, of course, in this case, in terms of cost, convenience, flexibility, and portability, right? Like you get slightly higher cost and higher convenience with fully managed configuration, but you lose on flexibility and portability, right? Because, well, some of that stuff is going to be Amazon only. And if you say, hey, I want to have the same Kubernetes environment across any cloud vendor and on-prem and everything, probably that's going to be self-hosted configuration. With that, I would say that the cost is relatively small. Unless you're running like hundreds or thousands of Kubernetes clusters, it is not very large, right? I mean, it's just around $70-something per cluster at this point, which is not as big as difference between, let's say, RDS and Aurora, right? Or self-hosting your Postgres and on EC2 and RDS. How do you run databases on Kubernetes if you're convinced what you wanted to do it? The first one is you want to use mature, well-tested operators for mission-critical production operations, right? Because that is a software which will manage your databases, which will be responsible for taking decisions, well, to do a failover, how to do whatever upgrades, backups, and it will basically take responsibility for your data. So you want to absolutely make sure it works flawless. The thing of Kubernetes, though, is you can also just grab a container, let's say MySQL, Postgres, wherever, and throw it in on Kubernetes. And you can do that in development, right? But for production, you need something more sophisticated with lifecycle management, with high availability, and so on and so forth, right? And that is what operators provide. And what you also want to make sure is to learn database-specific best practices on Kubernetes, right? Or Kubernetes specific best practices for databases, right? Because there are quite a few. I mean, I have a different presentation about the best practice for running database on Kubernetes. I don't have time to get into that right now, but you need to check it. Now, I think if you look at the operators, though, is to understand if that kind of high level of automation and reducing the toil and over reliability and the good stuff, Kubernetes operators also reduce flexibility. There are support certain formats of deployment for high availability and so on and so forth, and they are not as flexible, right? But again, for majority of people, that is the way you want to go. And again, because a lot of operators are open source, if you can say, hey, you know what, I want to do it my way, you often can customize the operators to support what you want to do. When it comes to Percona, we provide the enterprise grades, but also open source operators for MySQL, PostgreSQL, and Mongo, which are run by some of their most mission critical companies. So I would suggest you to check it out. Though I would say there are other good open source operators on the market as well. So what is the usability of Kubernetes operator? Well, if you think about that, on one extent, it really provides a lot of day one and day two automation and helps us to reduce toil, similar to database service solution or fully managed solutions such as Amazon RDS. But also user experience is quite different, right? And that requires understanding Kubernetes and expertise, right? And that's maybe kind of too tough for some users, right? Compared to saying, hey, it just takes me, 2 clicks to deploy the database on Amazon, and I will, right? Compared to all that, YAML mumbo jumbo on Kubernetes. If that is a problem, right, I would encourage you to check out their solution, which is called Open Everest. That is something which we spun up from Percona. It was previously called Percona Everest, if name sounds familiar, right? And this is their open source database focused solution, which is based on Kubernetes, right? It's is now has been accepted as CNCF project, right? And it's is really maturing very, very rapidly. And also, if you are looking for observability with good understanding of database, but also Kubernetes itself, I would check out the open source observability solution, which is called Karoot, which is just so easy to use and so seamless in Kubernetes, I would suggest you to try it out. This is not none of those last two are Percona projects, but these are close friends of ours. Okay. So as a conclusion of this section, what AWS gives us a lot of choice when it comes to databases, and a lot of a great choice of those is open source, derived and open source compatible databases. As we discussed, you can run them in a variety of ways, and really there are merits in those different approaches. There is not a single path which is optimal for everyone, and my goal was kind of to educate you so you have information you need to make that choice wisely. One thing to highlight here, I think, is what this new cloud native way or Kubernetes based way to deploy databases, I think, is very cool. It's kind of growing rapidly in a mindshare and adoption, because really it gives you that sort of like a very, I think, sweet spot between your convenience, flexibility, right, and avoiding vendor lock-in and being able to, run your data in the same way anywhere you want. With that, let me also make a couple of unrelated announcements. One is if you may have heard about Percona Live, which is a conference we run at Percona for many years. It's kind of was on a pause after pandemic, but now we are bringing it back, and we'll have two events planned for this year. The closest is coming by in San Francisco Bay Area in Mountain View in the end of May, and then we'll follow up with another event in Europe and Amsterdam in September. And then I would also highlight what Percona is celebrating 20 years this year, and we have created their special websites kind of for that, to maybe learn about our story, and even this Moments Percona 20.com website, which where we crowdsource their images kind of related to Percona, Percona story, right there. You can both sort of see what other people submitted as well as submit yours. With that, that's all I have, and I appreciate it. Thank you.